So now we're going to have a look at a question from advanced mechanics. So the question says, on a diagram, show the components of an initial velocity vector. Why do we assume horizontal acceleration is 0? All right, so let's draw over here on our answer page what a diagram looks like. We're going to assume that the object leaves from the origin. It might have an initial velocity vector that looks something like this. So this will be VI, initial velocity. There'll be an angle down here which we'll call theta. Now show the components of the vector. Well, there are two components here. There is a horizontal component. I might change color to do these. We have a horizontal component going this way. This is the velocity vector which we often refer to as V initial in X. And then, we'll change color again, we have another vector, this one going directly up. This is what we call V initial Y. So these are the two components of the initial velocity vector. One of them is in X and one of them is in Y. So this is the answer to the first part. Why do we assume horizontal acceleration is 0? Okay, so this is a very specific assumption. We assume acceleration in X is 0 because we assume gravity is the only relevant acceleration. So in a standard mechanics problem, you assume away most accelerations. The only one that you keep is gravity. Gravity, in the way that we've two-dimensionalized these problems, only affects the y-axis. Gravity pulls directly down. So we have an acceleration from gravity that pulls downwards, and we have nothing else. So this means we just ignore any horizontal accelerations. That means we make them 0, and then we let the vertical acceleration be gravity, and that's all, right? We solve problems on that basis. And that's roughly true in most circumstances. When you get to higher levels of physics, you stop doing this. You start assuming, quadratic air drag, wind resistance, or other types of accelerations. You might have magnetic field accelerations, etc. But for this kind of mechanics, this is the answer we have.